Hello, this is Mr. Huber. In this lesson, we're going to learn about writing equations and inequalities. This is very similar to writing expressions, where we had a collection of numbers and variables. The difference now is that we're going to add an equal or inequality sign into the mix. So, for instance, an equal sign, right? There's the symbol. We know that means things are equal. And there's some other words that we could see that might tell us we're going to have an equal sign. Is the same as. This symbol, greater than, and then greater than or equal to. So greater than, that means whatever's on the bigger side of the sign, greater than whatever on the smaller side of the sign. Okay, or sometimes people remember it as eating the bigger number. Okay, so is greater than. Okay, you could also say is more than. So we want to be aware that there's different words we can use, just like when we talk about sum for addition, we could talk about more than. The difference now here is that we have the word is more than. So that's when we're going to see that greater than sign. More than, that's not going to be just adding onto something. So look for the word is to be an indicator as well of when you're going to have an equal sign or an inequality. And then we have is greater than or equal to. At least. If you have at least something, you have that amount, or it could be equal to that amount. That's why we have the greater than or equal to symbol underneath it. Okay, no less than. If you have no less than something, that means you have that amount or something more than it. So sometimes you got to be careful with these words and think about the situation and what symbol might go with that. Then we have the less than or equal to. So again, look for the word is, less than, that's different than just less than, which would be subtraction. Is fewer than. We also have some of the ones that are a little different, like at most and no more than. So look for these words. We're going to start to get comfortable with how we can see them and write them into an equation or inequality to go with our algebraic piece with the numbers and variables. Some more terminology, so when we see them, we're comfortable with them. An equation is a mathematical sentence with an equal sign. Okay, that's where we have the equal. Is the same as. The inequalities, where we have the greater than or less than sign. And then an open sentence is any of those. So that's a mathematical equation or inequality. So just be familiar with those terms. So we see equation, inequality, and open sentence. We know we're writing something a little more than an expression. Now let's practice writing some equations or inequalities. The first problem says the sum of twice a number r and 3 is 11. So what I'm going to tell you to do here that I think helps simplify things is look for the word that's indicating where the equal sign or inequality sign would be. So it's going to be right here. Okay, right? The is. So that's my equal sign. So let's put an equal sign there. On this right side is 11. So I'm breaking it down into smaller chunks. Now I can look at the other side of the equal sign and just write this out separately. So I'm not just going to start here and just start writing and writing and writing and writing until I get to the end. Look for what's breaking it up between the left and right side of your equation or inequality, and then write each side separately. So now we want to write the sum of twice a number r and 3. This is like when we were writing expressions before. So we can be a little more comfortable with that. Sum means we're adding. What are we adding? Twice a number r. So how would we write out twice a number r? 2r. And 3. So it's a sum of twice a number r and 3. That would be my equation for this situation. If we look at the next one, and again, you can try these, and then as you see me do them, see if you're on the right track with that. So the quotient of a number n and 2 is at most. So right here, is at most. This is where we have to go back and think, okay, does that mean it's not an equal sign. Do I have a less than, a greater than? Do I have an equal, less than, or equal to? Okay, if you have at most something, it means you have that amount, or it could be less than that amount. So we're going to have at most be less than or equal to. Okay, if you have at most 16, that's the highest you could have, or you could have something underneath that. So right, we're going to put the 16 on the right side there, and then we want to write the left side now based on the quotient of a number n and 2. Quotient means we're dividing a number n and 2. So n over 2 is less than or equal to 16. In number 3, we have a number m is at least 5 and less than 17. This is a little different situation here too, because we have two different inequalities, right? We have is at least 5 and less than 17. So how are we going to write that out? Well, let's write out the first one and second one, then we'll talk about how to put them together. So m is at least 5. That means m is greater than or equal to 5. Our second one is that m is less than 17. So m is less than 17. When we see the word and here, that indicates something else we need to do. So the word and, okay, is going to indicate that we need to write this together as one inequality. How can we do that? We're going to switch around this first inequality here, where the smaller number now is going to be on the left side. So we're going to rewrite this as 5 less than or equal to m. And now we can combine it with this one by just bringing this over, because we can also say m is less than 17, all as one inequality. So that's an and inequality. We're writing down here that m, the number m, is both greater than or equal to 5 and also less than 17. It's both of those at the same time. So when you see that and, we're going to write two different inequalities and figure out how can we put them together. When we do that, it's typically going to look like what you see here, where you've got the smaller number on the left side, the bigger number on the right side, your variable in between, and you've got your less than or equal to's or less than or equal to's, depending on if you want it to be equal to the number or not. We can be equal to 5 in this situation. We can't be equal to 17 because less than 17. 17 is not less than 17, so we don't want to have the equal sign there. So those can be tricky. We'll get some more work in on practicing writing those compound inequalities with the and in there. Let's talk about when we have an equation or inequality, what it means for the value of the variable to solve that equation or inequality. Okay, a solution is a value that we can substitute in for the variable and it makes the open sentence true. Remember, open sentence just means an equation or inequality. So it means we take a value, plug it in for the variable, and see if it actually works. See if it solves and makes true the equation or inequality that we're working on. Here's some examples. We want to check whether the number we're being given is a solution for the equation or inequality. So the first one's an inequality, right? We have the less than or equal to, and when w equals 5. So that means we can take 5 and we can plug it in here for w. So let's do that. We're going to have 2 times 5 minus 7 is less than or equal to 3. Right, just substituting a 5 in place of the w. So this would be 10 minus 7 is less than or equal to 3. That would give us 3 is less than or equal to 3. That's true. 3 is less than or equal to 3, so w equals 5 is a solution. Now in the next example, number 5, we're going to take a 4 and plug it in for the d. We have 18 minus 3 times 4 equals 6. That's going to give us here 18 minus 12 equals 6. 6 equals 6. That is true. 6 equals 6. If we'd gotten 7 equals 6 or 6 equals 12, something that wasn't true, then it wouldn't be a solution. So yes, d equals 4 is a solution. And write that down. Make sure it's clear that you're indicating you know that makes it a solution because it's making the open sentence true. Both of these came out to be true so far. Let's try yet one more example here. Number 6. We have 11 plus 3m is greater than 5 when m equals negative 2. So we're going to plug a negative 2 right, in here for m. So we have 11 plus 3 times negative 2 is greater than 5. This will be 11 plus negative 6 is greater than 5. That gives us 5 is greater than 5. 5 is not greater than 5. Okay, right? That is not true. So not a solution. Yeah, there could be other numbers that make it a solution, but not the number negative 2. Right? And be careful plugging the negative in there, where it's 11 plus negative 6. If you make a mistake with the negative sign, you might get 11 plus 6, which is 17. That's greater than 5, and you might think it's a solution. So again, be careful with those negative signs. But it makes our open sentence not true. 5 is not greater than 5, so that means that number is not a solution for that particular open sentence. All right. Let's talk about some dice. There's mathematics involved there, but we want to talk about something not mathematical here, but the name for those dots on a die. There's 6 sides. You got 1 dot on one side, 2 on another, up to 6 dots. There are actual names for the dots that you see on a die. So we see the die pictured there, and another picture next to it, which might seem like it has nothing to do with this particular situation and this question I'm posing, but it does. That's Gladys Knight and the Pips, and it's not named for them, but the dots on dice are called pips. So there you go. Dots on dice are called pips. And Gladys Knight and the Pips, very famous Motown group. All right. more example here where we can apply what we're using to some type of real world situation. Okay. Last season, Joe Dumars, going back in the day, or a famous Piston here, not as far back as Gladys Knight and the Pips, but Joe Dumars, a great Piston from years past, scored 471 points in the first 2 months of the season. If he plays 24 games the first 2 months this year, will an average of 20 points per game be enough to beat his total from the previous year? So if we want to write an inequality that would go with this, we want to see if he plays 24 games, okay, and averages 20 points. So 24x, where x is going to be the number of points he averages, will that be greater than 471? Greater than, not equal to. We want to beat his total. Beat his total, okay, means greater than the total, not equal to it, right? And in this case, we can take the 20 and plug it in here for x. In 24 games, if he scores 20 points a game, okay, we want to see if that's going to come out to be greater than 471. So 24 times 20 is 480, greater than 471. Yes, so he would know that if he averages 20 points per game in those 24 games, he'll have more points he did at that same point the season before. All right, so we can write the inequality there. 24 times whatever his average is, so he's getting that many points total for the amount of games he's playing and how much he's scoring per game, and we can find out if it will be greater than the situation we're looking for. That's the kind of opportunity where we can use an inequality in a real-world situation. So remember, when we're breaking these down, find where your inequality is, okay, and write out one side and the other separately, because then you're breaking it down into smaller chunks that are more manageable. And a solution for inequality is something that makes it true. Similar in this real-world scenario, 20 would be considered a solution for that inequality we wrote, so that we know 20 points a game would be a true number of points that he could score and beat his previous year's total. So we see some more examples of writing these out, applying them to real-world situations. Keep in mind those key phrases we can look for to indicate where that equal sign or inequality is, because that's going to be the key then to linking up the two sides that are expressions on either side of that open sentence.